Yesterday we learned trigonometric ratios or some standard angles. Today we'll deal with some questions relating to it, and also we'll learn trigonometric ratios of complementary angles. Example: in triangle ABC, right angled at B, AB equals to 5 centimeter and angle ACB equals to 30 degree. Determine the length of BC and AC. So this is not an issue, this is one of a simple questions. Right angled at B is C is our base angle, so let's take this as C, 30 degree, and this becomes our A. So what is given is this C is given as us as 30 degree and AB is given to us as 5 centimeter. So what we have over here is the perpendicular and the angle. If we have to find BC, that is the base, we'll need a trigonometric ratio that deals with perpendicular and base. Because we have perpendicular, we have the angle, we'll be able to find the base. So what will we use is tan C equals to AB by BC, perpendicular by base, which implies tan C is tan 30 degree, which is equals to AB is 5 centimeter by BC is BC. We need to find the value of BC, which implies tan 30, value of tan 30 is 1 by root 3. You'll need these values memorized so that you can perform the calculations well, which implies BC equals to 5 root 3 centimeter. So we found the value of BC. Now we need to find the value of AC. Now we have the perpendicular. So what deals with perpendicular and hypotenuse? Sine theta. So sine C is equals to, some people have, okay, one more thing, if when you have found the base, you can also use cos C, because you have the base, you will be able to find the perpendicular. So sine 30 degree equals to 5 by AC. Sine 30 is half, equals to 5 by AC, which implies AC equals to 5 into 2, that is equals to 10 centimeter. So we have found the value of BC and the value of AC. Proceeding on to the next question. In triangle PQR, right angled at Q, PQ equals to 3 centimeter and PR equals to 6 centimeter. Determine angle QPR and angle PRQ. So in the previous question we were given the angle and we were supposed to find the value of the sides. In this one we are given value of two sides and we need to find the value of angles. So solution, we are given a triangle that is right angled at Q. So let's make a right angled triangle. So this is right angled at Q. We have P, Q and R. PQ equals to 3 centimeter and QR equals to 6 centimeter. So PR equals to 6 centimeter. So we have the base, we have the hypotenuse, let's say cos P. So cos P will become curly round here, PQ by PR. So this is equals to PQ is 3 by PR is 6. Cancels off to become half. Half is cos of what angle? Half is cos of 60 degree. So we'll replace half with cos 60 degree. Sin 30 degree is also half, but since in the left hand side we have taken cos, we'll replace with cos. So this implies cos P equals to cos 60 degree, which implies P equals to 60 degree. So angle P is 60 degree. Angle P means angle QPR. QPR. This angle is 60 degree. One more thing, whenever you have cos P equals to cos 60, do not cancel cos and cos. That would be completely wrong. Once you have cos P equals to cos 60, just write directly that angle P equals to 60 degree. And by angle sum property, angle P plus angle Q plus angle R equals to 180 degree. So 60 degree plus 90 degree plus angle R equals to 180 degree, which implies angle R equals to 180 degree minus 150 degree, that is equals to 30 degree. So we have angle P, we have angle R. Therefore, angle QPR is basically angle P, that is 60 degree, and angle PRQ equals to 30 degree. So this is our solution. So these are the two types of questions that you get, and the last and the final type of question that you may get over here is of this type. If sine A minus B equals to half cos A plus B equals to half, and A plus B lies between 0 degree and 90 degree. A greater than B, find A and B. Solution. This is again very simple. What is given to us is sine A minus B is equals to half. So this implies sine A minus B equals to half is what angle? Half is sine 30 degree. So sine A minus B equals to sine 30 degree, which implies sine and sine, we can remove sine and sine, so we get A minus B is equals to 30 degree. And we are given cos A plus B equals to half, which implies cos A plus B equals to cos half is 60 degree. See, cos of 60 degree, the value is half. So half will become cos 60 degree. So cos and cos we can remove. We get A plus B is equals to 60 degree. So this is equation 1. This is equation 2. Adding 1 and 2, what we get? A plus B is equals to 60 degree and A minus B is equals to 30 degree. When we add them, A plus A is 2A, plus B minus B is cancels off, 60 plus 30 is 90 degree. So this implies A equals to 90 by 2, that is 45 degree. Now from 2, A plus B equals to 60 degree. From equation 2, which implies 45 degree plus B is equals to 60 degree, which implies B is equals to 15 degree. So these are the values of A and B. So these are the major three types of questions that you will get. One confusion that I want to clear is that please note that sine of a plus b, this is not equals to sine a plus sine b. Just one example to prove this: sine of say 90 degree. Say we write this as sine of 60 degree plus 30 degree, sine 90 left hand side, which is equals to sine of 60 degree plus sine of 30 degree. So let's take left hand side. Then left hand side is sine of 90 degree. Sine 90 is 1. Right hand side, sine 60 degree plus sine 30 degree. Sine 60 is root 3 by 2 and sine 30 is half. So this becomes root 3 plus 1 by 2, that is greater than 1. Hence sine 90 degree is not equals to sine 60 degree plus sine 30 degree, and sine of a plus b, further we can say that, is not equals to sine a plus sine b. Here is a simple proof of why sine a plus b is not equals to sine a plus sine b. This is valid for cos as well as tan and other trigonometric ratios as well. This is not true. This does not hold for any trigonometric ratio. Next, we begin with trigonometric ratios. Of complementary angles. Okay. So the sign that we learned, sine theta, actually comes from the word sine, sine. We use sine. The complementary function of sine is cosine, from which we derive cos. They are complementary to each other. That's why complementary from co. Then we have secant. The complementary function of of secant is cosecant. From secant we use sec, and its complementary function is cosec. So the complementary function of sec is cosec. And tan is derived from the word tangent, whose complementary function is cotangent. So they are complementary to each other. So there is a simple way of learning the formula. Sine of 90 degree minus theta becomes cos theta, because complementary function, sine's complementary function is cos. Cos 90 minus theta will become sine theta. Sec 90 minus theta is cosec theta, and cosec 90 minus theta is sec theta. Tan 90 minus theta becomes cot theta, and cot 90 minus theta becomes tan theta. They are complementary to each other. Here is a simple proof for this one. Let's say a triangle is here. We take a triangle, right angle triangle, 90 degree. So this is theta. Let's take this as base. Let's take this as perpendicular. Let's take this as hypotenuse. Okay. We know the total angle in a triangle is 180. So if we remove 90, we are left with 90. If we further remove theta, so we are left with 90 degree minus theta. So if one angle is theta, the other has to be 90 minus theta in a right angled triangle. Now let's take the first case. So sine 90 degree minus theta. So sine of 90 degree minus theta. This becomes our base angle. Some people half. So we get b by h. Cos theta, curly, if we are taking theta, this becomes our base angle, so curly brown here. So this becomes b by h. So sin 90 minus theta is also b by h, cos theta is also b by h. Hence sin 90 minus theta and cos theta is equal. You can show the same for each and every one of them. Please do not get confused with this notation b. This notation b is used to denote this side. Sine of 90 minus theta, we are taking this as the base angle. So this will become the perpendicular in this case. So that is why sine 90 minus theta is b by h. So this is the basic proof for these angles. These are different formulae for complementary angles. The formula is not very difficult, but we'll first see how to convert from one to another. Say cos 65 degree. So we need to convert this into sine. There are two ways of doing so. Either we can write this as cos of 90 degree 65. 90 minus 25 degree is 65 degree. So either we can do this. Now cos 90 minus theta is sine theta. Or for conversion, you may use this method. Cos of 65 degree is equals to cos theta is sine 90 degree minus theta. We'll just subtract the angles, so we'll get sine 25 degree. You can use either of the method, but I personally prefer this method because in many scenarios this will prove much more fruitful as compared to the first method. Again, let's deal with some examples. First example, first type of questions that you will get is to evaluate the values. I'm not taking very difficult questions. These are basic questions, but the method will be same for almost all of them. So evaluate tan 65 degree by cot 25 degree. Solution: tan 65 degree by cot 25 degree is equals to, either you can change the numerator or the denominator. Do not change both, change any one of them. Say we change tan. So I'll use the second method. Tan theta is cot 90 degree minus theta. Over here our theta is 65 degree by cot 25 degree. So this is 90 minus 65 is 25 degree by cot 25 degree. So this cancels off to become 1. Second type of question you get is, you will be given a certain equation. If suppose sine 3a equals to cos a minus 26 degree, where 3a is an acute angle, find the value of a. Solution: so given sine 3a equals to cos a minus 26 degree. Now this is the example where second method will prove much more easier as compared to the first method, because we do not have any fixed value of the angle. So sine 3a we can write as sine theta is cos 90 degree minus theta. This is equals to cos a minus 26 degree. So cos and cos we can remove them. Please do not cancel them. I am telling them again, do not cut them. So cos and cos, after removing, 90 minus 3a equals to a minus 26 degree. 3a goes that side, 26 comes this side. 90 degree plus 26 degree equals to a plus 3a, which implies 116 degree equals to 4a, which implies a equals to 116 degree by 4. That is equals to 29 degree. So the value of A is 29 degree. The final type of question that you may get here is express cot 85 degree plus cos 75 degree in terms of trigonometric ratios of angles between 0 degree and 45 degree. Solution. This may seem quite difficult, but this is one of the simplest questions you can get. So cot 85 degree plus cos 75 degree, this is equals to cot, if you need to change into tan, so cot theta is tan 90 degree minus theta, plus cos theta is sine 90 degree minus theta. I am changing both of them because we need to show the angles between 0 degree and 45 degree, and both of them are above 45 degree. So tan 90 minus 85 degree is 5 degree plus sine 90 minus 75 degree is 15 degree. So both the angles are between 0 degree and 45 degree, hence it has been expressed. So we are done with the question. So these are the three types of questions that you may get in trigonometric ratios of complementary angles. We are done with this portion for the lecture. We will have 2 more lectures, and those 2 lectures will be the most important lectures of this chapter. These are also important, but they will consume most of the marks that comes from trigonometry.